Welcome to clickmyproject.com, and now we will discuss and demo of a Manifold Embedding and Semantic Segmentation for Intraoperative Guidance with the Hyperspectral Brain Imaging. Then abstract. Hyperspectral imaging is to obtain the spectrum for each pixel in the image with the purpose of finding objects, identifying materials, or detecting processes. Hyperspectral imaging is a non-contact, non-ionizing and minimally invasive sensing technique. Until today we use only the dimensionality reduction technique, and now a new processing pipeline are introduced to obtain a detailed tumor classification map for intraoperative system due to brain surgery. In the tumor classification technique are performed to demonstrate the potential clinical value of the system. Now we introduce the new technique. This is called the Manifold Embedding. These outputs are generated from the hyperspectral image is semantically segmented into a tumor map. Using this technique, we can extract the exact boundaries of the brain tumors and it allowing a complete resection of a malignant cells while saving as much as healthy brain tissue as possible. Then data flow diagram. First we load a data set. Then by using IMD function, we select a correct type of file from the data set. Then we must follow the three important stages: pre-processing, manifold embedding and semantic segmentation. In pre-processing, we have three steps. First one is image calibration, then data normalization, then noise removal. In image calibration, we follow the image resectioning, that is the rotation of image. In data normalization, we can change the range of pixel intensity values. In the system, we use the norm2 function. The noise removal, using IMNoise function, we can get the result of errors. At the end of pre-processing, we can remove the unwanted parts of image. Then we apply the manifold embedding technique. It is possible by IMAdjust function. Using IMAdjust function, we can adjust the brightness of image. By using contrast adjustment image, we can view the image in detailed manner. After the contrast adjustment, we follow the semantic segmentation technique. It is possible by random forest function. In this stage, we can extract only the tumor parts of brain image. After the tumor parts extraction, we apply the validation of this image. In the validation part, we must follow the three measures: accuracy, sensitivity and specificity. We can also follow the precision, recall, F measure and G mean. Using these results, finally we form a HCD demo of manifold embedding of brain tumor image. This is our command window. We can execute a single ML command in this space. This is our workspace. Now currently working videos are displayed in this page. This is our current folder details. This is our editor window. Now we run when the data set is loaded. Now we select any one image from the data set. This is our original brain image. This is the extraction of the components: red band, green band and blue band image. Now we apply the pre-processing technique. This is the first step of pre-processing. Image calibration. This is a 90-degree rotation image. This is a reverse rotation of image. This is the second step of pre-processing, noisy image. This is the third step of pre-processing, normalization image. Now the pre-processing stage is finished. Before starting manifold embedding technique, we apply the filtering technique. Now we apply the median filtering technique. This is the median. Then we combine the three median filtering. This is the 3 median. This is the combined image. Then we apply the manifold embedding technique. Using IMAdjust function, we can adjust the brightness of image. This is the original image. This is the contrast adjustment image. This is the histogram equation image. It is possible by IMAdjust function. This is the cluster index image. Using the extraction, we can get the tumor parts of brain image. This is the final extraction of tumor region. This is the original mode. This is the extraction of only 2 more parts, and we apply the performance by using 2 more parts. This is the performance comparison chart. For performance validation, we must follow the following measurements: accuracy, sensitivity, specificity, precision, recall, measure, and G-mean.
Accuracy is the more reliable than other measurements. Sensitivity is the number of positive values in the classifier. Specificity is the number of negative values in the classifier. Precision is the number of items labeled in the positive class. Recall is the fraction of documents that are successfully retrieved. F-measure is the combines both precision and recall. G-mean is the geometric measurement. G-mean is the type of mean and average.
Thanks for listening this video.